Hello guys, welcome to this channel, The Alpha Particle. Now, in this video, we'll be answering the question, photons do have momentum, but they don't have mass. Now, how is that even possible? Some of you might ask. Well, let's say we all have studied momentum is the product of mass times the velocity. Now, momentum is a vector quantity. So, we define momentum as P vector equal to m into v vector. So this is what we have been told about momentum, right? So now you may ask one thing. You said the mass of a photon is 0. So if we substitute 0 in this equation, then you should get the momentum of the photon and also to be 0. But that's not the case. In this video, we will be analyzing this concept and I'll be explaining why photons have 0 mass but definite momentum. Okay, so for those of you who are new to this concept, photon is a light particle, or to be precise, it is a quanta of electromagnetic radiation. Okay, so it travels with the speed of light, in the speed of light. So it's equal to, we know that the speed of light is equal to 3 times 10 to the power of 8 meter per second. Or to be precise, if you want to Google it, you might get something like 299,792,45. I'm not sure though, but this could be the value, I think. So this is the speed of light, and photon also travels in the same speed. Now, according to special theory of relativity, Einstein proposed that anything that travels in speed of light should have 0 mass. Now, how can you say that? Well, we all know an important, very famous equation of Einstein from special theory of relativity. That is E equals mc square. Sounds familiar? Yes, it is. So, if we consider this equation, this is actually not a full equation, expanded equation. It is just a simplified form of a more complex equation. So, the original equation goes on something like this. E square equals P square C square plus M naught square C power 4. So this is the exact equation that the Einstein gave. This is called as the energy momentum relation. And this equation is called as the mass energy equivalence. Well, you can say it's pretty much easy, right? We can, this much of mass can be converted to this much amount of energy, and if you have this much amount of energy, then we can attribute it to the mass by this following relation. So that's what it speaks about. Now, if we consider photon, the mass is 0. Now, the formula, there are two kinds of masses in special theory of relativity and general theory of relativity. One is the rest mass, and the another one is the relativistic mass. Now, coming to the rest mass, it is actually the mass that we speak of in day-to-day lives. Whatever we say mass, we just refer to the rest mass of the substance. That is the mass that is possessed by an object at rest. Okay, so how can I prove that? Now, there is a relation between the relativistic mass and the rest mass in special theory of relativity, and that is given by m equals m naught by root of 1 minus v square by c square. Now this may all seem weird, guys. I'll just erase off these equations so you might not get confused with this a lot. Now m naught is called as the rest mass of the particle, that is the rest mass when photon is at rest, and m is the relativistic mass of the photon at an instant when it is in motion. Now you can say that whenever the mass of the body increases, it tends to move, right? Now how can I say this? Photon cannot be at rest in vacuum. It is actually a rule. Like you can even think of it like an axiom. Photon cannot be at rest in vacuum because it is massless. Now how can we prove that it is massless? We saw E equals mc square, right? So m should be equal to E by c square. Okay, so m should be equal to E by c square. Now what have I said? This m is actually the relativistic mass here. Okay, and this can be written as this. So m naught by root of 1 minus v square by c square is equal to E by c square. Okay, so after some manipulations, then we might get the equation m naught equals E by c square root of 1 minus v square by c square. So this is the final equation, and we can prove that the rest mass of photon is 0 by substituting the value of v in this equation. Now, what is the velocity of the photon? It is equal to the speed of light. It is equal to c. So v equals c means, substituting in this equation, we can get E by c square 1 minus c square by c square, which is actually 1. So E by c square of root of 1 minus 1, that is root 0, and it's finally going to be 0. So m naught of photon is 0. And it's not only true for photon, anything, any particle or anything that is traveling in the speed of light should have 0 rest mass. Okay, so the mass of the photon is 0. Now we have proved that in mathematical way. Now if you want to explain it to someone in somewhat an intuitive or superficial way, you can say that photon cannot be at rest in vacuum because it is massless. Okay, it has energy because how can we know that it has energy? Because it can show photoelectric effect, it can show Compton effect, and these depends on the energy of the photon. If you remember, in photoelectric effect, the energy of the photon is being attributed to the work function of the metal and the kinetic energy of the electron that just escaped from that metal surface. Okay, or in case of Compton effect, the transfer of energy of a photon to a stationary electron plays an important role in that equation. So photons certainly do have energy and they are in motion, they cannot be at rest. So it has energy, it is in motion. Therefore, it should have momentum. Now, how can we find the momentum? Now, recall the formula that I have told. E square equals P square C square plus M naught square C power 4. Okay, this is just the full version of that E equals MC square equation. Now, this E is actually equal to mc square, because this m is relativistic mass and this m naught is rest mass. I will just explain it in the further steps. So right now this m naught becomes 0 for photon. So E square will be equal to P square C square, that is E will be equal to PC, and P will be equal to E by C. Now we can see from this equation that the momentum of the photon varies directly in proportional to its energy. Okay, so now this is what we can infer from special theory of relativity, that is P is equal to E by C. Now if you want to push a little further, we should consider quantum mechanics. Now according to Planck's radiation law, E is equal to h nu, right? E is equal to h nu, where h is the Planck's constant and nu is the frequency of incident radiation. It is the energy possessed by a single quanta of radiation, that is a photon. Okay, now substituting this value in here, we get h nu by c. As you can see, the momentum of photon is independent of the mass of the photon, that is the rest mass of the photon. Now you can also say that nu is equal to c by lambda. There is another formula, right? C is equal to nu lambda, where c is the speed, nu is the frequency of incident radiation, and lambda is the wavelength associated with the photon, incident photon. So substituting this equation, we get hc by lambda and c getting cancelled, and p is equal to h by lambda. This equation sounds familiar. This is an important equation and a very famous equation. This is called as de Broglie's relation. So this proves that photons do have a definite momentum but zero mass, rest mass. Now there may be another question that some of you might have. Light bends near the gravitational objects, or the objects that have extreme gravitational pull. Now this is due to the fact that now some of you might wonder that only the object that is having mass can be attracted towards another body by the principle of gravitation. Now that is not that cannot be applicable here, because the space-time fabric, if we consider the special theory of relativity especially, just forget about the Newtonian gravity here, because Newtonian gravity just rely on the mass of the body, but we are not going to consider the mass of the body here because it is irrelevant here. Now we say that the light is independent of doesn't have any mass, right? So how is light bending whenever it comes near a gravitational body, you might ask. Now space and time are actually a kind of fabric like substance. It's like some fabric. Okay, so whenever there is some mass that is placed in the space-time fabric, the sheet around the fabric bends. The sheet around the fabric bends. Now light follows a rectilinear propagation, that is, the light tends to travel in a straight line. But since the space-time fabric itself is in bent shape, the light is forced to follow that bent shape irrespective of its mass and momentum. So this is the fact that light actually bends in presence of a gravitational body, and photons have definite mass but photons have no mass but definite momentum. If you like this video, then do subscribe to our channel, like this video, share as much as possible. And if you want to know any other concepts, then do leave that topic in the comment section, and I will look forward to it. I will see you in the next.